Hello, learners. So, this is the video in which we are going to learn data modeling in very detail. And this video is going to be from basic to advanced, and it will be covering all the concepts in the single video so that there would be no more confusion to anyone. And this video is going to be very helpful for beginners also, and for those who are gonna appear for some kind of interviews, right? So, let's get started with this video. So here we are going to learn the introduction of data modeling, fixed and dimension tables. How do we identify these fixed or dimension tables using foreign key and primary key? We will be learning about schemas and the different three different kinds of schemas here, and then ways to create relationship in Power BI. Then we will be creating a data model for a real time data tables, right? And that data tables will be present in the link below in the description. You can download from there. And then we have different kinds of cardinalities. We have a different type of filter flow direction, active and inactive relationship, and finally we will be seeing different points, important points to remember while creating data model. So let's see what is data modeling. Basically, data modeling is a crucial step in building effective and insightful reports and dashboards. In real time, it's not mandatory that the developers will have only one table and your client will ask you to develop reports or insights. In real time, there may be or there will be multiple or n number of tables. In such case, you will need to create a data model. Data model means if we will be having multiple tables or more than one table, then we need to join those tables and then develop business insights to solve the business problems. That means we need to create data visualizations post that. It involves shaping and transforming your data to create a structured and optimized data model that supports the visualization and analysis requirements of your business. So basically, for example, if I have one customer table, right? Before that, let's see if I have uh, e-commerce store, and in one table I am storing the customer details when any customer signs up on my e-commerce website, right? Then here my customer id will be the unique column, that is the primary key. Primary key means the column which have all the unique values, uh, without duplicates and no blanks. Then I have one product table where I am storing all my products, right? Here my product ID will be the primary key. So here this product ID will not be the duplicate and can never be blank. Now I will be having my sales table where I will be storing all the sales values, right? Whatever all the transactions are there. For example, my customer C01, that is David, has purchased some product from my e-commerce website, right? So that particular transactional details will be present in my sales table. Here if you see, customer id from this sales table and customer id from customer table are common, but in sales table we can have duplicate customer ids because a single customer can purchase from my e-commerce website multiple times, correct? So that is my foreign key, and this customer id cannot be blank in sales table, right? So that will be the foreign key. Same as product id will also be my foreign key in my sales table, and this is the common column between sales table and product table. So I will be connecting these tables, customer id from sales and customer table and product id from sales and product table, to get connected among these tables, right? So if I am opening my sales table, and do I need my data model? Because for example, if I have sales table opened and I just want to see who is this customer id with C01, right? I don't know what the name or the customer details, so I'll require to go back to my customer table and will check, right? Same as product id. Let's say C01 customer has purchased P02 product, so I'll have to go back to my product table and check what is P02. So without joining, I will have to just go back to different tables and then come back to my sales table and see more transactions. But if I connect all these tables all together, then my tables will get be filtered out using the joins whatever I make into it, and I can just query into my sales table itself and it will be visible from without moving to customer table or product table or some different table. So that is why my data modeling is important. Now, uh, what are fact tables? So there are basically these. We have understood what is data modeling and why do we require data modeling. Now here you have seen we have two different kinds of tables, where we have primary keys and where we have transactional data, and we have uh, we can have duplicate records but cannot have null records, right? So we have uh, different kinds of tables here. Now let's see what are those. So we have fact tables and dimension tables. So fact tables are also called as data or master table, right? So master table means the one in which we have the master data. So if you see here in this diagram, you will understand what all kind of data we have, right? So we have data or master table. We contains quantitative data that represents transactions or events, right? And it holds numeric measures or matrices, where we have data like sales, revenue, quantity sold, profit or expense. So here we have sales table for that, right? So sales table is my fact table. Now we have transactions or specific events that include foreign keys. Foreign key basically means we can have duplicate values but will not have the blank value. So this is our foreign key. Now this fact table grows rapidly with time, and this growth basically leads to large fact table in size. Because let's say there are 100 customers, and at a single day 25 customers have the purchases for two or more products, right? So we have rapidly growing data for that. So for every customer, every product, we have a record added. So that's why rapidly growing with time. For example, e-commerce business, right? So the example I given to you, so that is orders table or the sales table we have. Now if you see, we have this sales table here. Here we have this customer ID and product ID, where we have duplicate values but we cannot have we cannot have the blanks. So these are foreign keys, correct? So this is the first identification. Second one is we have price and quantity. So the price of one product and the quantity sold. So these kind of transactions are going on into this table. So this is the fact table with us. So these are the two things using which we have identified our fact table. Now we have a second kind of table as dimension table. So dimension table is also called as lookup table or the mapping table. So this is called this way because we have the data where we have just linked our customer ID from sales table to customer table, because we just wanted to see what is C01, who is customer C01, right? So we have linked these two tables, right? So we are just looking up these values. That's why we are calling it as lookup values or the mapping table. It contains descriptive data and provide a way to categorize, filter, and group the data in the fact table. So descriptive data means, so this data will be the least to this data will be least increasing. And the only time it will increase will when a new customer signs up or a new product is added up. So this is rarely increasing. So we have fewer records as compared to a facts table, and stores attributes like customer details, product details, or the addresses. And it contains primary keys, which creates relationship with the fact table foreign keys, correct? And the example are customer table, product table in the e-commerce business. So how we can identify dimension tables? So as I told you, dimension table contains primary keys. So customer table and the product table contains the primary keys. So we cannot have customer ID and product ID duplicated. So this is the identification, and it contains lookup values, and the data here is rarely increasing data. Now we have the other thing as schemas. So basically the schema is defined as the organization, structure, or relationships of data within a database. So in a for example, in a database we have three tables: sales table, uh, customer table, and product table. So the way we are organizing, structuring, and relating these tables is considered inside a schema. So we have three different types of schemas: star schema, snowflake schema, and galaxy schema. So let's see all these one by one. So in star schema, we have one fact table at the center. Then we have multiple dimension tables. So these dimension tables are connected with the single fact table through foreign keys and primary keys, right? So the foreign keys are present in fact table, and the primary keys are available in our dimension table. So we can have n number of dimension tables, that is we can have more than one dimension tables present. So this is the star schema. We call it star schema because we can see call it in the form of a star, right? So that's why this is called as a star schema. Now we have second one as snowflake schema, where we have one fact table and we have multiple dimension tables. Now this is the star schema. So how it is differentiated with snowflake schema. So like we have multiple dimension tables connected with dimension tables. So we will be having single fact table here, right? This single fact table is connected with multiple dimension tables, and these dimension tables are further connected with other dimension tables. So this is extended star schema or the snowflake schema. Now we have galaxy schema, where we have two fact tables and they are connected with dimension tables. Fact table, two fact tables are connected with common dimension tables, right? And some dimension tables are not connected in common. So this is galaxy schema. So two fact table, further they are connected with dimension tables, and these dimension tables could be the commonly connected with these fact tables or uncommonly connected. So this is galaxy schema. So galaxy schema is made only when we have more than one fact table. Star schema is the most common schema we use to create in Power BI reporting, right? Now, there are multiple ways to create relationships. First one is auto create new relationship. Then we can have drag and drop columns, and we have added relationship tab option. So we will be learning one by one. So basically, what are the requirements for creating relationship? We have two requirements, only two things we need. First is one common column in a fact table and a dimension table, and some same data type of the common columns. So let's say we have customer ID common in our say a fact table and a dimension table. So in customer table and in orders table we have common customer ID, so it should have the same data type. So this is the basic requirement for creating a relationship. Now we will be just importing our data set. We have these number of tables with us. So this data set is available in the description link below, right? You can download from there. we have we are using this data as e-commerce data, and this is a real-time data set, but we made available by a company called Olist, which is available on Kaggle website. So I have this data from Kaggle website. So that means this is not the copyright data, but I have made some modifications here for this tutorial, correct? So here we have these tables: order table, customer table, data, delivery status, payment mode, products, sellers, and reviewers. And we have orders table as the fact table, and others are dimension tables. So let's go back to our Power BI and connect these tables. So I am here into my Power BI desktop, and the data files I have are available to us in CSV format. So I am connecting the data files one by one. Data modeling. Here we have the data sets, right? So I am connecting it. And so I don't require any formatting here. So I'm just directly loading it. see, my first customer tables is loaded here, right? So I'm just pausing my video and I'll be back once I have loaded all these datas here. See, I have imported all my data sets here. We will be checking the quality of these data one by one. So we have customers data set here, right? Here we have customer ID as the column, the primary key, right? If I just click on it here, you will see there are all distinct values here. If I go to delivery status, you will see the columns as column 1, column 2, and so on, right? Here the headers are not promoted. Now orders data set, we have these this as the fact table, right, as we earlier see. Now we have payment mode. Here we have the order ID, right? Now we have products data set. Here also we have product ID as a primary key. We have reviews data set. Here we have review ID as a primary key. Then we have sellers data set. So we have here the seller ID as the primary key. Correct. Now one transformation we require. So this is the transformation we require for the delivery status data set. So we will be going to transform data here, right? Here I'll go to this delivery data set. Here I need to just go to my home tab, and here the first row is header, right? So this will promote my first row as the header, and that's all the thing I need to do, right, as of now. So here I have more. Let me just check all the data types here, right? For customer data set, it's okay. For my delivery status, we have this column should be in the date format. So I'm just using this as date time format, right? I'm just adding a new step here. Okay, it is just changing it to the errors, or let me just uh, leave it, right, as of now. So I'm just going back to my home, just Power BI desktop, by applying these changes. So that was the primary change actually, or primary transformation I had to do to just promote the headers actually, right? So these are my date columns that are kept untouched as of now, right? So I can just change the data type from here also. Yes. So this we can do as of now, right? uh, Now we have the thing. If I just go to data model view, so I am just one thing to note here, I am not touching all these data types, because this is the tutorial for data transform data modeling. So we will be focusing on the data modeling part moreover, right? So these transformations are necessary before just data modeling part. But uh, as of now we will be covering data modeling. So if I just go to my model view, here you will see the relationships already created here, right? So if I just go to my ppt, and here I was telling you that there are automatic there are ways to create relationship, right? The first one I was telling you, auto create new relationship after data is loaded. So this is the first way to create the relationship. So Power BI has the inbuilt intelligence to just create the relationships, right? To see how uh, Power BI does so. So we have one feature enabled here. So we will be have to go to file, options and settings, options. One window will open up, right? Here we have for current file data load. Here we have detect column types and headers for unstructured sources, and in relationships we have auto detect new relationship after data is loaded, right? So here we have this option already automatically enabled. So due to this enablement, Power BI automatically loads the relationships. So if I just turn it off and click on OK, so Power BI will not be able to load the relationship once any more table comes into the picture. Now I'll arrange these tables in a sequence way. So orders, customers data set, here the delivery data set in the above way, right? But the question is why we are just, if Power BI has this intelligence to load the relationships automatically, then why we are learning it even? So why why we are not like giving the Power BI its functionality to load the relationship, and what's the need of ads to load it? So sometimes we need to modify the relationships, correct? So that if we have different scenarios, somewhere we have different kinds of uh, lookouts where our data is where we need to perform some other kind of things that this data model is not performing, right? So in those cases we have some different kind of data modeling models required, or the relationships required. So for that we are just learning these data modeling, right? So in the center we have ordered status set, because we have this as the fact table, we have this customer table, delivery status table. All other tables are the facts table, dimension tables, right? So review data set, let me keep it review below sailors, this way. Now you will see few of the relationships are all the relationships are highlighted, right? Or the solid lines, but one relationship is dashed line. We have some arrows here, somewhere we have written as one, somewhere we have written as star. So what's the meaning of that? So if I just hover over any relationship, it's highlighting the columns, right? The common columns. So these are this means that if I'm hovering over any relationship, it's highlighting the common column. That means we have the relationship on the common columns only, right? So I'm just deleting these relationships. We will be creating our own relationships, and I will tell you each and everything here. What are these arrows means, what is one, and what is this streak means, right? Now my relationships are removed. Now if I just show you, we have uh, the second way, drag and drop columns from two tables, right? The second way I was showing you to create the relationship. So if I just show you the customer data set and the orders data set, we have the common column as order customer id, correct? So if I just drag this customer id to, to the customer id in orders data set, right, the common columns, it will create me one relationship, customer id in both the tables. So you will see customer data set here and the orders data set here, and it has all automatically created suggested me the cardinality, cross filter direction, and the common columns are highlighted in both the tables. Now uh, ho- I hope you all know the concept of SQL joins. If you don't know, that is also fine. So this is the left table and this is the right table. Just think like that way. So cardinality means one to many. That means in customer data set we have only one single columns or the non-duplicate values, and in orders data set we can have duplicate values. So the one particular value in customer data set will map to many values, or many values in customer id, right? So that basically means like for let's say 4E7B, first value in customer table may have multiple times in our ordered status set, right? So this will be mapped from one value from this customer data set to the primary key column, and many values from this customer id from order status set. That means the cardinality, right? So if I just save it, I'll tell you the cross filter direction. So this is the relationship created. So if you see one and this is a streak. So that means one value from this dimension table will be presenting multiple times in the orders table. So that's why one in the dimension table and many in the facts table, and the direction is the arrow. So the filter cross filter direction is in the direction of this one to many. Correct. So this is the kind of relationship we have created. Right. If I just go back to the slides, so this is how we saw the second type of relationship with us. The third is the edit relationship tab option. So I'll show you that also. Before that, I'll show you one thing. Right, I have already shown you to creating relationships. So one kind of relationship I have shown you. The second the concept here I'm telling you is cardinality. So if I just show you in my Power BI, right? So if I just right click on it and go to properties here, the same added relationship tab opens up for this value. So now if you see, from table is now above and to table is now below it. So the cardinality got opposite. Right, so here cardinalities of four types. So what is this basically means? So now going back to my slide once, right? So the uniqueness and the relationship between two values in two common columns when creating relationship between tables. So the unique relationship that we create between the values of the columns in two columns, right? And the type of relationship we create in the tables is the cardinality. That means one to many or many to one. So how many values the first table will filter in the second table, or how many values from the first table will get mapped to the second table, right? So that is the cardinality. So it defines how, that's the thing I was telling you, it defines how many rows in one table corresponds to rows in another table. That means one customer ID in the customer table will be connected to multiple customer IDs in the sales table or the orders table. That means one row is reflecting multiple rows in the orders table, right? We have four different kinds of cardinalities: one to many to one, and many to many. So here, many is represented by n. In one-to-one relationship, each record in the first table is related to only one record in the second table, and vice versa. This type of relationship is relatively rare in data modeling, but can be useful in certain situations where you need to split large tables for performance reasons, or where you have optional attributes that can be stored in one table, right? But Power BI Runner will not recommend to create one or two one relationship. Instead of using one to one relationship between two tables, it's recommended to add these two tables in a single table and then use that into a data model. Now we have one to many relationship. This is the most common relationship, right? In this data model, in this type of cardinality, each relationship in the first table can be each record in the first table can be related to multiple records in the second table, but each record in the second table is related to only one record in the first table. This is a standard relationship type used to connect dimension tables to fact tables in the star schema. So this is the one we have seen in our example. Now we have the third kind of relationship as many to one. This is same as one to many, but it is reversed. So multiple rows in first table corresponds to a single row in a second table. Now we have many to many relationship. In many to many relationship, each record is in the first table can be related to multiple records in the second table, and vice versa. This type of relationship can be created, but it creates data ambiguity. So it's essential to use bridge tables or the DEX measures to resolve the relationship and performance accurate calculations. These are less common and are usually resolved using bridge tables. So both tables are foreign keys, right? Now we have active and inactive relationships that we were seeing there. So one were dotted lines and one were solid lines. So in Power BI we have already know that we have two kind of relationships, active or inactive, and these relationships impact how data is connected and used in the reports. So let's talk about active relationship. So this is a default relationship that Power BI uses when querying the data. It is the primary relationship that determines how data are related and how data is aggregated in visuals and calculations. When you create multiple relationship between two tables, Power BI automatically identifies one of them as active relationship based on the data model's cardinality and direction of the relationships. So it is used for standard calculations such as summing values, filtering data, and performing aggregations and visual measures. Now we have inactive relationships. An inactive relationship is the additional relationship used when querying the data, and this is not the used by default. It isn't intended to be used by selectively depending on the analysis requirements or user interactions. The inactive relationship does not affect standard calculations or visuals directly. Instead, it allows us to use custom calculations using use relationship functions index. So this use relationship function enables you to override the active relationship and specify which relationship is used for a specific calculation or visualization. This gives you more control of over the data, how data is related and displayed in certain scenarios. There can be only one active relationship, but there can be multiple inactive relationships. So these multiple inactive relationships can be handled using use relationship function. Now we have the use case here that I have told you. We can add relationships to calculated tables also. Now, firstly, let me show you creating other relationships also. Here, just a second. Yeah. So, I we have created this relationship right now in delivery status and our orders data set. So we will have to find the common column here. Here we have order ID and here also we have order ID. So we will be dragging order ID from this table to this table. So this will create a relationship, and if you see this cardinality in one to many, that means we have this in this order ID we have primary key, only one particular value of this ordered ID will map to multiple values here, right? So that's why one to many relationship, and I can save here, right? It means this active relationship is now created. If I hover, if I just right click here and go to properties, here it is showing me single directional. That means it is the single arrow, right? This single arrow represents that this is single directional. Cross filter direction is single. Why it is called as filter direction? Because the one value from this order id is filtering multiple values here, so one to many. So this is single, so one value here is getting in here multiple times. So one where direction is filtering, so one direction is there for filtering purpose, right? So this is why single. Now here also in payment mode we have order id, and here we have order id common column. So in simple terms we will be just add dragging order id from payment mode to order id to order status set, right? Here also one to many, because one order id here and multiple order ids here. So that means this is the primary key and we have foreign key here, and we can save it. So when filtering is done from primary key to foreign key, in that case we have the in that case we have one directional relationship. Now if we want to create using third method of relationship creating, so if I go over the slides and we if I show you the third method in schemas, ways to create relationship. Now we have the third method is edit relationship tab option. So this edit relationship tab option is nothing but this manage relationship option, right? If I click on it, it will show me this manage relationships tab. So these are the three relationships that we have already developed, right? And to just create new relationship, I will just click on this new relationship option here, and the same this new relationship tab will come up. Now here from I need to create product data set, and from to which table I need to create order data set. right? It has automatically detected the common column here, right? And it has automatically detected the cardinality and cross filter direction. So here we have make this relationship active or inactive. So by default, as of now, we will keep it active. So if it is not detecting properly, then you can just change the common columns also by clicking on other columns. So here we have the common column as this. So product data set has unique column as common column is product id. This product id is the primary key, so only one unique value here. All the values are unique, and here repeating values, so only one value will match here with multiple values. So that's why one to many and single direction. So here we have either single direction or both direction. So both direction is used only when we have a foreign key in both the tables, right? So if I click on save, we will see a new relationship will be created between these two tables, right? New relationship is added. Now I'll create one more relationship between the seller status set and my order status set. Now it has detected seller ID as the common column. Again, seller ID in the seller status set is the primary key, and this is the foreign key. So that's why one to many, one unique value here, and multiple repeating values here. So this is cardinalities one to many. We can save it, right? New relationship is created here. See, now we have a reviewers table remaining, so we can create new table relationship from reviews also, and order status set also. Here it will detect. It's bit loading. Yeah, loaded. So here it has not detected the common columns, but here we have review id, and here also we might have uh, reviews. Okay, so we don't have reviews as a common column here, so we cannot create the relationship here, right? So product id customer, so we cannot create the relationship here, correct? So we are just leaving it, and we can close it, correct? So if I just go here, order date, and so the relationship would not be created. Now if I just show you the slides, we have created the relationships, right? Now we can create the relationship with a calculated column also. So I'll be creating a calculated column, right? And will this calculated column will be the column for related to date column, right? So I'll just go back to my Power BI desktop. Here under the table view, I'll be creating one new table under the home tab, new table. Here I'll be renaming it to calendar table. Here I'll be going with the calendar function. Start date will be the minimum of the order state, order date, and the maximum of order date, right? If I just press enter to execute this, so start date and calendar function cannot be minimum and maximum, so I think that should be okay. If I just go with max here and minimum here and execute it, so you will be seeing the maximum value to minimum value, it is going with 63 rows here, right? Now I'll go to my data model here. You will see my date calendar table is up now. This calendar table can be created. This calendar table will be like connected with my data set. Here I will be connecting my date from orders date here. So let me drag it with order date, right? And just let me load it, right? Common columns, and click on save button here. This is also created. Now if I just show you like the active and inactive relationship, the concept of that. Now let's suppose my scenario comes into the picture where I need to just show the shipping concept of shipping date. Let's say my scenario changes, and I just wanted to show that after how many days of order my shipping happened. So I need to create the relationship of this orders table to that shipping date as well, right? So I need to create one more relationship here, right? If I just create this relationship, you will see this dotted line is coming up, right? So this is the inactive relationship that I already told you that there could be one active relationship and multiple inactive relationships. So we cannot have more than one active relationship between the two tables, right? Between two common tables. So this is why this inactive relationship comes here. Now going back to the slides again. Filter flow direction. So I have already shown to you the filter flow direction determines how data is propagating between related tables. This flow direction is controlled by relationship cardinality and filter direction, right? So we have two types of directions: single direction, that is the default one, and both direction, that is bidirectional. So if we talk about single directional, the filter single directional is used when we have one to many relationship or many to one relationship, and it is represented by single arrow that I already show you. And the lookup table filters the fact table, or the dimension table filters the fact table, right? And it improves performance and prevents unwanted circular dependencies. The scenario where we have to use single direction filter flow, it is recommended for performance and simplicity, where we have to improve the performance and simplicity, where the relationships are naturally flow from lookup tables to fact tables, where optimized query performance should be there, where we have to avoid circular dependencies. Now the second type is both directional, right? Yeah, or bidirectional. So in this case filter flow happens in both the directions of the table, that is many to many relationship comes into the picture, right? Many to many relationship means both the tables will have foreign keys, not the primary key. Both the tables will have foreign keys there. So this is represented by double sided arrow, and both the tables will filter each other. And many to many relationship or the complex scenario will be there where fact table needs to filter a dimension table. Now where we will use both direction filter flow, it will be using with a caution, right? Caution or the alert, where you need to filter lookup tables based on fact tables. In case of many to many relationship views, where we are dealing with hierarchical structures, right? Now we have controlling filter flows in text. So for example, we have filter flow direction, single direction or multi direction. So we have text functions as cross filter or use relationship function. We can use these functions to modify or control the filter flow direction. Now we have important points to remember before we create data model and while creating data model. So creating data modeling in Power BI requires careful considerations and attention to deal to ensure the accuracy, efficiency, and usability of your report and dashboard. So the first point we have is data source quality. Ensure that your data source is reliable, clean, and consistent. Check for data quality issues such as missing values, duplicates, or incorrect data types before importing the data into Power BI. That is the ETL part. Data transformation, next point is our data transformation and cleanup. Use Power Query Editor to clean and transform your data, remove unnecessary columns, handle missing data, and apply data type conversion appropriately. This step is crucial for preparing the data for analysis. Next point is our relationships. Establish accurate and meaningful relationships between tables. Check the cardinality between tables to avoid incorrect aggregations and results. Make sure the relationship reflect the actual business logic and join keys. Next point is avoid many to many relationship. Try to avoid creating many to many relationships as they can lead to data ambiguity and incorrect calculation. Use bridge tables or resolve many to many relationships using DEX measures if necessary. Next, we have use hierarchies wisely. Create hierarchies to enable users to navigate easily through data but avoid creating the too many levels in the hierarchy as it may overwhelm users and make report cluttered, right? Next we have data model simplification. Keep your data model as simple as possible. Avoid redundant or unnecessary tables and relationships which can lead to confusion and increased maintenance overhead. Next point we have row level security or RLS. Implement row level security to restrict data access based on user roles and permissions. Define appropriate roles and filters to ensure data privacy. Next, we have optimize for performance. Optimize your data model for better performance. Use incremental refresh dealing with large data sets and be mindful of the number of visuals and data points in the report. Next, we have test thoroughly. Validate your data model thoroughly to ensure that the relationships, calculations, and visuals are working correctly. Check for data discrepancies and verify the accuracy of key matrices. Next, documentation. Document your data model, including relationships, calculations, and data sources. This documentation will be valuable for you and other team members who work on the report in the future. So this include data refresh also. Set up scheduled data refresh to ensure that your reports always display the most up-to-date information. Then we have version control. If you work in a team, use version control for your Power BI files to track changes and avoid accidental data model modification. Remember that data modeling is an interactive process and you need to make adjustments based on feedback and changing business requirements. Power BI provides a powerful environment to create robust data models and derive valuable insights from your data. So, the conclusion of this tutorial is we have learned how to create data modeling. What is what are the cardinalities we have? What are the basic requirements we have to create the relationship? What is the filter flow direction, active and inactive relationship, and why we have left out reviews table because we don't have a review. We don't have common columns here in this these two tables, right? So we have successfully developed our data model here and we saw the important points while creating data model. Hope you are pretty clear with the concepts. If you are having Q&A, you can post them to in the comment section. And happy learning.